Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host, Shafu, and today's episode we're gonna look at Reflex, which is a Solidity framework written by the guys at Chroma. To walk us through that, we have Jack on and zerosnacks. Jack, why don't you briefly introduce yourself, introduce Chroma and Reflex?
Cool. So I'm Jack. I'm the founder of Chroma. We're building some interesting stuff in the lending space. It's a bit out of scope for this conversation, but when kind of researching that, and when we really got started, we bumped into like a number of issues ranging from like contract size issues to like architectural issues that led us to researching and developing Reflex, which is a framework for building really like upgradable modular smart contract systems. It comes with some really interesting bells and whistles that help you, when you're building a much larger system, things like reentrancy locks and a bunch of other stuff. Zerosnacks did a lot of the heavy lifting there when it comes to the development, so I'll let him kind of give his story and introduce himself and talk a bit more and dive into the details there.
Thanks for having me. I go by zerosnacks. I've been involved with the Chroma for a while, and recently, since the start of the year, I've taken a step back from my previous role, where I was leading the smart contract development and developed Reflex. And I've recently joined the foundry team at Paradigm as a core contributor, but I do remain active as an advisor to Chroma as well. Um, so at high level, jumping in, Reflex. The background of Reflex is that most smart contracts combine architectural decisions and business logic, as in like implementation details live inside of business logic, and this is a pattern that you see very commonly in early languages. So this is something. So we've seen in many other languages a transformation have been made over time away from everyone building their own abstractions or like no abstractions to sharing snippets of code. We could then like formalize these into libraries, but then as these things evolve, frameworks appear. So this is something that we see in like TypeScript or like JavaScript. Many like Rust, many other languages, you get these frameworks that abstract away certain complexity, but also certain make it easier to reason in things like modules or things abstraction levels like that. So the current level Solidity does not have these kind of frameworks, as in like the popular shared code code are just libraries and where you pick and choose whatever you need, be it like OpenZeppelin or Solidity or like Soulmate. But it fundamentally does not enable you to reason in these terms of like modular components. So this is something that came up when we were first designing Light, which the lending protocol, and we thought about, okay, how can we split this out? How can we make this a useful component and make this available to the public? So given my previous experience writing like open source libraries, specifically in like the TypeScript space, but also, I figured it made sense to create this level of abstraction where we can start reasoning about modules and modular code and how this fits together. So there was an opportunity there. So Reflex is not a final implementation, but I really see it as a conversation starter around abstraction and introducing levels of abstraction to Solidity and creating reusable code where people can think in terms of modules. So Reflex, as the name, you probably people understand, is a nod to React, the popular framework, and it also refers to like React, the Fiber compiler, and this idea of being able to write really high level syntax, then having like magic kind of performed in the background, allowing you to just be able to reason in terms of like React modules or React. So it's kind of like that. It's Reflex is a lot more low level than that, and it doesn't have these level of abstractions. But this is what the idea is. And at a core level, it is a formalization and an optimized implementation of something that Euler proposed in their V1, which is the Euler proxy pattern. And it takes some inspiration from EIP 2535, which is the diamond standard, and it specifically handles function selector clashing, and it allows you to run multiple standard compliant modules side by side and solves various other kind of issues around the diamond proxy standard. These specifically. So I think it makes sense to kind of start jumping into the code. So we have a lot of documentation. I think at a high level note, it probably makes sense to just briefly walk through the README, and then we start digging into the code. So as described, reflex has a couple of traits that I think are important. It works around this maximum contract size limitation. It avoids the function selector clashing. This is something that is raised quite often, and I do note that the Diamond standard has proposed a way to kind of work around this, but this wasn't available at the time, and people weren't thinking about this. It is very optimized. It is. We reasoned a lot about, okay, how can we get as close as like this idea of a zero cost abstraction, because that's ultimately what you're looking for. Uses neutral language, no like Diamond standard naming here. We support these high level things which we call modules. We have single endpoint modules, multi-endpoint modules, internal modules. I'll go into detail on that later. So we have a built-in installer, which is very interesting. So this is a formalized flow of being able to add, upgrade, and deprecate modules throughout the application lifespan. And it has a global reentrancy lock. It does not use the T-store because this was developed before that, but it is something we could look into. I touched on the motivation, so I think it makes sense to start digging into the contracts here. So let me jump into the dispatcher. So the dispatcher is the place where it is the central contract. It is the place where all the storage is contained. And so all operations that interact with storage inside of modules, they actually map to the storage of the reflex dispatcher. People will use so reflex is designed to be inherited, right? So we have a reflex template. We can look into this later, but basic idea is that you inherit from the reflex dispatcher and you just instantiate it and you get access to a couple of methods. So on a constructor level, we register the installer upon installation, initialize some variables. I think the best way that I can describe this is that let me jump to the reflex storage, because as you know, the reflex dispatcher inherits from reflex storage. Getting into this from a higher level, then we describe the storage, we describe the constants, and we'll jump back. So the reflex storage, we use the namespace storage layout, and this is very important because we are using multiple modules mapping onto the dispatcher. If you have two things overriding each other in slot 0, that's a big problem. So there's a proposed standard. It came from Open Zeppelin, I believe. Their latest V5 version is using this layout. So we had an implementation before, but we upgraded it to match the specification. So the idea is very simple. We define a slot, a predefined slot for reflex, like variables, but anything that the user defines, they are required to define something along these lines, along the spec, define the storage location at a hash point, and then map their storage from there. This is how we also do storage inside of modules.
Seriously, one question.
Yes.
Why not take the reflex storage slot and then do the +0? Why always pasting in the actual address?
That's a good question. I think at the time, the way that we're using this is just to point. I believe that there was a technical reason why it is declared like this. I don't fully remember, but it's something that Solidity probably didn't allow me to do. The reason why it's defined here as explicitly as it is also because we're using this for tests and just being able to make sure that stuff isn't shifting around. We do have a struct that basically is the same thing, but it allows us to either directly talk to the slot or directly talk or use the storage layout struct. So it is this is the most common way that users interact. But yeah, for specific things, I think when you need this access in assembly, you are required to define it as a uint. I don't know. There's something there. So at a high level, we have a reentrancy lock. We have owner. We have two-step ownership. Then we have a mapping of modules, a mapping of endpoints, something I will touch on, and a mapping of relations. And a relation is basically a registered module and an installed module. So when you install a module, it becomes part of this trusted relation set, and this way we allow to link the call made through the endpoint to the dispatcher dispatched to the module, so we can verify the entire flow. So unregistered modules or like strange things they can't directly call into. So you cannot also directly call the dispatcher. It doesn't function like that. So let's hop back let's quickly go to the constants. It's very simple, but we have a couple of definitions that describes these things that I mentioned earlier, which are the endpoints. We have the reentrancy guard state. We have the installer. We have reserved slot number 1, but basically any module that you add afterwards just increments from here. So jumping back to the dispatcher, hopefully that kind of makes more sense because we're going to dig into lower level stuff soon. We have a couple of things registering, but what is important here is the installer, because this is something that we mount inside of the dispatcher. Upon construction, we register it as a default module. It is also, I don't believe we can uninstall the installer itself, but it's just an entry point, right? It's like a bootstrap kind of thing. So let's jump into the installer from there.
Before we go into the installer, it might make sense to go over a couple of the graphics in the implementers file, just to show like how, like, what is an endpoint, like in a more abstract sense, what is a dispatcher, and like kind of what is like the flow of one single transaction. Like these diagrams like really help like drive in the core, and then we can go kind of module by module and like what matters there.
Yeah, that sounds good. Let's do that. So we in our docs we have an implementers file. This is like the where the README is high level. This is very low level. It does make sense to describe this flow. I was going to do this a little bit later, but here's a good flow. So a user sends a request to a module endpoint, and an endpoint we will go into this later, but an endpoint calls into the dispatcher using the
zerosnacks, so a user in this case is an EUA or a wallet or something.
correct. Yes.
Oh, okay.
Yeah.
Okay.
And Euler refers to something as something similar here as a proxy, but it is quite a different than what most people perceive as a proxy, which is why I decided to rename it to an endpoint, the entry point of interaction, the endpoint. Yeah, it's and it uses call, so it doesn't use delegate call because it uses the storage inside of the dispatcher. So in the dispatcher, we then perform a delegate call to the module implementation. This gives some kind of response. We have some kind of logic that is processed there, and then that response is being passed back to the user. So this is the kind of the one directional flow, and then we have a response tree back.
I have a question here.
Yes.
So the module endpoint is a contract and the module implementation is another contract?
Correct. Yes. Yeah. So you can have multiple endpoints for a single module, which is the multi module. Let's go through this. So at high level, we have single endpoint, multi endpoint, and internal modules. Let's focus on single and multiple. Single is what is used like 99% of the time. It's the most straightforward thing. Multi endpoint is an edge case. The idea is that you have a single mapping from a single endpoint. You construct this. So I can explain this. When you in the installer, when you register a module, so you create a module, you create a module and then you register it through the installer. At that point, an endpoint is created by the installer, and that becomes the point where the user interacts with the module in the system. We'll go through this in the installer.
And that's also where the correlation is drawn between that endpoint and the implementation contract.
Correct.
And so just to interject, so now there's a relationship between this endpoint that kind of, it's not really a proxy because there's no storage, but it knows what implementation contract to interact with to understand what logic it has to do when a user's calling functions on that endpoint. And so now we have this kind of relationship set up there. And all execution will occur in the dispatcher with one sort of centralized state of storage. Keep going.
Yes, correct. So the multi-endpoint case is something quite special in the sense that we create multiple endpoints pointing to the same module implementation. This is for something like an ERC20, where you have a single implementation, but you have multiple endpoints mapping to that. So let's say this would be a USDC, a USDT, a RAT ETH kind of endpoint. They all share the same implementation. In the same logic basically, and this allows you to do things quite efficiently in terms of storage management, but also upgrading these implementations. So you don't have to maintain all of the individual things. And then we have something called internal modules. These are very similar. It's basically just a delegate call kind of thing inside of a module, and it's able to extend its own storage or extend its own functionality to other modules, and this is used a little bit, but yeah, as I said before, this is the single endpoint case is the most simple, but also the one that most people will use.
Okay, so zerosnacks. So to summarize, you basically have you can have one or n endpoints. All of them go through the dispatcher, and then you can have basically one implementation. But one implementation can basically call one or n sub implementation. I forgot what you've called it. If you scroll up again through the delegate call.
Oh, yeah. Here. Yeah.
No, if you scroll up,
Oh.
the one, yeah, it's internal module.
Oh, okay. Yeah,
Okay.
exactly. Yeah, you can just think of internal modules as like an extended an extension of the current logic. So this is something that internal modules are special in the sense that they don't have an endpoint themselves. So they're not meant to be interacted with by a user. It's just a way to contain. This is a place where this idea of a module or like a developer thinking in terms of modules really works and really applies.
Okay. And this is how you can circumvent the size limit, right?
Yes, correct. Yeah. So the way that we circumvent the size limit is that is through this dispatcher. We install modules, and modules are basically self-contained. If a module exceeds the size limit, which shouldn't happen, because then you're not designing your modules correctly. You're not like breaking down your models enough. But if you need to contain certain logic, or you want to contain certain logic, you can use these internal modules as well. Yeah.
Nice.
So let's touch on endpoints here. A thing that's interesting is that where modules are upgradable, in the sense that you can swap out the logic, endpoints themselves are non-upgradable contracts, and this has a nice effect in the sense that it's very similar to proxies. Users can just keep calling the same address with the same kind of they can just keep calling the same address. One thing that Reflex is different than the Diamond proxy standard here is that where the Diamond proxy standard has a single kind of entry point, it's like as if you would talk directly to the dispatcher. Because we need to work around this issue of function selector clashing, which we can touch on later. We need to be able to have these different endpoints, have these different addresses. This gets a little bit more complex, but it's the idea is that this kind of management happens outside of the application, very similar to like a registry. People maintain a registry of contracts. So this is a downside, but it has a good reason. As mentioned before, forwarding method calls from external users to the dispatcher. What's interesting is that by default, all endpoints share the same code. We'll jump into that. The idea is that it's a very simple contract. It just forwards calls, but what is crucial is that it appends the original message sender to the call data, and this way the dispatcher can know who is the original caller, because from a dispatcher it just sees a call coming in. Its knowledge of just a message sender, as in Solidity, would be the endpoint, not the user. So this is why we have to do that. And this is something that Solidity allows, this kind of flexibility of appending to call data. It's kind of out of bounds, and it's kind of a thing in the language, but it's basically stated that this is accepted use of, but it is kind of strange, of course. We also touched on this, which is the relations, the trusted relations. We will jump back into the installer soon, and then we'll jump back to the implementers, I feel. Yes. So we're in the dispatcher. The dispatcher registers the installer in its constructor. This is the place where management of modules happens, right? It's the bootstrapping place. It's a place where we define an owner of the contract, And this owner, the way that this works is that because all modules share the same storage, they can use the storage of the other modules, right? So when you register a new module, you know who the owner is. You have this much broader context, and this is why, it has some big advantages. I think more of that will become clear later. Just some basic management. I think what's interesting is the adding of the modules. Please note that all of this is behind only owner modifiers, which is like the idea is that the application has a lifespan. Modules get added over time, modules get deprecated over time, but if you want to rescind your ownership of the system, it's a very trivial thing to do, and it's at one point in the application, which is you can just renounce ownership, and from that point on, it becomes a static application. And because this is one of the things that is complex about large systems with a lot of proxies, is that who has ownership, is everything renounced, all of that sort of stuff. So this is quite nice because it's easy to verify for anyone what the state of the program is, and it also allows you to evolve, right, in a very natural way from an early stage application where maybe there are a lot of moving parts, maybe you want to add a lot of stuff, and then it freezes over time. It's so this is also one of the core properties that we wanted to explore with Reflex. And this is I'll touch on this. One thing, so we have this thing called hooks. They're really quite simple, but they're just I think Soulmate implemented them first. But this just allows the implementation to hook into the thing at certain points and just perform extra checks, such as like is this part of a set of modules that we accept in this application, like a whitelist kind of module, or you can imagine all kinds of things. So if we jump into this, the create endpoint, this is in the module, because what's interesting, of course, is that Reflex installer actually is itself a module, and so let's jump into there. It does something very similar, but it's quite crucial in that it points to the endpoint creation code. The creation code, this can be swapped out. You can overwrite this. This gives extra flexibility, but this also means that modules themselves can define how they want, what kind of endpoint they want to be spawned on themselves, and this gives extra capabilities if you need to work around specific things. We have an ERC 4626 that uses custom endpoint, but for the most part, people will use the same endpoint. So let's dig into the endpoint first, because then things start to make a little bit more sense. So let's think about where we are at, right? We are a user. A user is the way it will interact with the endpoint. I described this at a high level, but also let's dig into the code line by line. We have something very similar. We create a upon construction, because the Reflex endpoint is created by the installer. We know that the message sender is the dispatcher, and from that point on, we are able to create this kind of immutable link and be able to check against it. So because endpoints need to be extremely small, extremely minimal, because it's assumed that we spawn a lot of them, it's assumed there are quite a few, so they just have to be cheap. which is why we're using quite a bit of assembly. Let me go to the else case first, because that's the base case, and then we can go back. So the idea here is that a user calls the endpoint with call data, and that call data is basically formed by the user interacting with the interface of the module that is applied on top of the endpoint. So let's say we have like a set number method uh, on the module. Instead of actually calling the module, we call the endpoint. It's very similar to like you call the proxy instead of the implementation. Yeah, it's close to that. So this means that we have at this point we have message data coming in. What we do is that we append the message sender here to the message data at the end. This is what allows us to decode it in the dispatcher. And then we have the use of the call. Again, very, very different than a delegate call, right? Because where does storage happens in the dispatcher, not in the endpoint, not in the proxy. And we have a special case here, which is if the dispatcher has certain logic, or let's say if the module has a certain logic that relies on logs being emitted from a specific address. So let's an endpoint would, for example, be like a USDC kind of derivative, right? So you have like let's say like a compound style, like a CUSDC. These kinds of logs need to be emitted at that address. Then they shouldn't be emitted at the dispatcher. So normally this would, because the actual logic happens inside the dispatcher, logs would be emitted there. This is a way of basically sending back the logs from the dispatcher up to the endpoint, and then emitting them inside of the endpoint. Yeah, it's specifically for standards. It's not really that relevant, but it just supports all the different ways that logs can be emitted.
This is interesting. But what do you do if you have multiple logs?
That's a good question. You can basically call the dispatcher can basically call this multiple times.
Okay.
That is just the way. Usually, it's like a emit of a transfer, right? Something like that. So critical logs that you want to be able to log at the implementation or at the endpoint address, not at the dispatcher. But yeah, this is it is a stateless function, this one. But yeah, it is there as a specific edge case. So I think endpoint makes sense at this point. Let's go to the reflex module, because this is also where the installer inherits from, and it's a core component. So a module we describe with a few properties, right? We have the module ID. This is the one that was one for the installer, but the user defines it. Note that these are marked as immutable, and they are assumed to be immutable because this is the way that we also establish this kind of trust relation. We have a little tag here, which was raised by a few people, which is quite interesting. It's something that Euler did in their code, which is very interesting. It's declaring functions explicitly as, okay, reentrancy is allowed here, and because and note of course there's no function body here. It's just a way of like explicitly tagging. So if you then run like a build script and and you perform certain checks, you can check, okay, are all functions properly? Do they have the proper modifiers, or are they missing modifiers, and what modifier does it need? Because it's very easy to miss, like a modifier that you should be applying, like a non-reentrant.
Nice. Yeah, this is interesting. I've never seen this before. Stating this explicitly.
Yeah, I thought it was quite interesting. Of course, there are very few places where you explicitly want reentrancy, but it gets you in this kind of mode of thinking. Other thing, just really kind of standard. Note that we are using very similar to Solidity. I got a question about this before, about error emitting. It's just a way of efficiently emitting errors, and it has a few properties that allows us to do, because it right now, of course, these are using S stores. We can use T stores and T loads, but of course, it's not everywhere supported everywhere. But this is one of the places where that kind of optimization could be useful. We have this thing, a non-read reentrant, which is very interesting. I actually contributed something very similar to this to the Solidity repository, and this relates to the curve read reentrancy bug that happened some time ago, and people are getting more familiar with this. But it's basically, if you have a view function and that view function is doing some sensitive logic, and it's not counted on being reentrant, adding this non-read reentrant modifier can be quite useful. It just performs a quick check: am I in a locked or unlocked state, and allowed to be read or not. So we use this quite a bit in Light. I think all of this is quite self-explanatory. Let's see. Yes, the create endpoint here. So this is the place that gets called when the installer, right? So let's quickly jump back to the installer. It's right here. So in the add modules, this endpoint is created. Here. Yes, as mentioned, the internal endpoints, of course, or external modules do not use endpoints. It quickly checks: do we already have this endpoint registered? Because that's because this is kind of reused throughout. So you have an early return here. We have this get endpoint creation code, which we pointed to earlier, that you can implement basically your own endpoint creation, your endpoint logic, and then we have a simple creation here. And this is interesting, or this is important, because this is the place where we register the trust relation, and from that point onwards, we are able to establish this trust chain throughout. We have a few utility methods here that are used quite a bit, not specifically in Reflex, but if you're interacting with or have an implementation that uses Reflex, you need to be able to, let's say, unpack the message sender from the bytecode, right? Because from the call data that you're getting, because the call data that you're actually getting, as you remember, you go through the endpoint, the message sender of this gets added, and it gets sent to the dispatcher. At the dispatcher level, we still have this chunk attached to it. Now we need to unpack it, right? And the endpoint address is also appended, which is also, we can also slice that off. So we just have two different functions. These basically do the same.
Yeah, zerosnacks, what are the gas costs of always appending message sender and the endpoint address into the call data?
That's a good question, but it's something that is necessary. It's not
Yeah,
a choice that we have of like not doing, but it's basically 20 bytes. We're packing them tightly. So yeah, 40 bytes
okay.
of extra call data, and call data is super cheap, right? So
Yeah,
uh, that's not really a concern, and it is a fundamental property that we do rely on. Um, I think let's jump back to the. I think we covered the installer quite a bit here. Um, One thing to touch on, of course, is the upgradability, because it is a core feature, and it it is in one sense quite a controversial thing. But if you dig into like most live systems, they have some kind of upgradability. Um, what Reflex does is be explicit about it and introduce these points where uh, where you are able to freeze or just make this upgradability very explicit, but at the same time allow you to um, make the application more robust over time. So that and so one of the core things here. Um, we have a couple of checks here, of course, is that, okay, are you ready? The module that you're registering is it actually, or are you upgrading? Is it actually the same module ID? Is it of the same type? Because of course that can cause problems if it was registered as an internal module before, and now as a single type, as a single module or something, that would cause issues. Um, and yeah, so we just at this point we just point to the new module implementation and then emit this event. So that's the installer. Let's jump back quickly to the dispatcher. Like Reflex is actually not a lot of code, which is the aim. But they're quite it's quite a few jumping back and forth, right? So we then through the constructor we have registered the installer. We can define a couple of modules that we want to install. This is something that you would usually do atomically in a setup transaction deploy script. And this is kind of the meat of it, right? Which is the dispatcher and being able to dispatch to the different modules. So at the endpoint level, we call into the dispatcher. That's where we end up here because yes, all of these other things are clashing in a sense. So inside of a module, it is assumed that you cannot implement the function selectors as described as here, right? So we want to keep this as minimal as possible. We've documented this, but it's something good to be aware of. But anything else falls back onto the fallback. Here we do a couple of checks, right? So the call data that we're receiving, we know it has the message sender appended to it, or at least it should. That's why we can perform a quick check here. Okay, we have the function selector and we have the message sender. If it's less than that, it can't match. It can't like it's an incorrectly formatted message, and we exit out of there. It's an edge case, but you also always have to be in this mindset of okay, how can malicious messages be crafted? We do a couple of things here. So the message sender from the Reflex dispatcher perspective is of course at this point the endpoint, and so not the caller of the not the original appended message sender, which we will slice off later and we can do stuff with. But this is just a quick way of S-loading the basically from the mapping without memory expansion, because this is a thing. If you do ABI encoding or things like that, you will run into this. So if you do it like this, you can avoid memory expansion. So we have a couple of things here. We extract the module ID. We quickly check, okay, if it's zero, because that just means that the relation wasn't found in the mapping. So that's when we exit, when we have this error, caller not trusted. So yeah, the call happened from an endpoint that is not actually registered, and this will fire in any case where this trusted relation isn't established. Then we extract the module implementation. We do that from the relation, and then we check, okay, if the module implementation is zero, then so this is a specific case where we have a difference between single modules and multi modules, right? Multi-endpoint modules. So if the module implementation is zero, load the module implementation from the modules mapping. This happens because, it's difficult to explain right now, but it is a core property of multi-modules, and it is what makes it possible. And you have another point here, which is these things are kind of separate, are kind of fit together, because we need to know the module implementation, and if that's not the case, we have a not registered module. So basically, everything that we're doing here is just establishing, okay, do we have a trusted relation? Do we have the implementation? Is the chain correct? Is the chain of interactions correct? If that's so, let's continue. We just copy the message data. We append the endpoint address. This allows you to do various other checks, but it is another way of establishing the source of the call. And that can be used in various other ways. But yeah, crucially here, this performs a delegate call to the module implementation. So this is where kind of this extension of core logic to dispatched to individual modules happens, and then we just return with the data. So it's really quite simple in the flow. There are a couple of little edge cases, a couple of a few checks, but this is kind of the general idea. I think we went through most of it. We have one special implementation, which is the reflex batch, which allows you for batched execution, which we use quite a bit. And this also ties into simulation that you can do, which is quite interesting. This is also something that we use really quite heavily in Light. So most importantly, it's a reflex module, right? You can just install it and using the installer, and it has a couple of things. You have calling of static call or performing static calls. This is something that you want to do during simulation. Okay, do I have the allowance that I need? These kinds of things, right? Is my balance more than this? These kinds of things. If you want to actually perform a batch call, or you want to simulate a batch call, these things are very similar. I'll touch on the simulation later. Here's a place where we use that unpack message sender, because we need to know, okay, who is sending, who is performing this batch call, and we actually pass that into the hook we have defined here. It's at the bottom, I believe. Yeah, we have two hooks. We have a before batch call. We have an after batch call. That's a place where you can implement specific logic. Light has some very interesting features how it uses that, so but yeah, to know like, okay, who's performing a certain operation, you need to pass in certain data, and the message sender is one of them. Then we just have a very simple for loop. We have perform batch action. Let me see. So these two do things very similarly, but in the simulation it expects a revert. Yeah. So let's jump into the actual perform batch action. We establish two things. It does something very similar again with the mapping, with getting into the mapping without the memory expansion. We've performed quite a few benchmarks on this, and it is kind of the right way to do. It's definitely helps in certain ways. In some situations it may not be worth it. I think this is a good point to touch on as well. Okay, which is the difference between business logic and framework logic. This is so reflex being written like this. You might say, is that really necessary? Is it? Should you do it? Should you do it this way? The idea behind reflex is that it's written once. You have one implementation. You don't have a spec. There's no EIP. It's one implementation, and it either is correct or it's not. And you want that specific implementation, that specific thing. You want that to be optimized. Then but in your business logic code, so light code doesn't look like this, right? It's a separation of concerns, and it's a mode of thinking, and it's basically getting closer to this idea of like any abstractions that we implement here, they should be close to like a zero cost abstraction, which of course it's not. It's a whole different thing, but getting into this mindset, we think that is very very important. And yeah, reflex batch is one of those kind of standard modules. We haven't tagged as periphery here, but periphery is a folder that we can kind of expand over time. But popular things, they can be added. They can be added there. So we do something very similar here. Because let's quickly go back. Of course, this is performed in a for loop, so it's get called multiple times. So we are able to collect the results, or just return the results. In the end, we have one part which is the delegate call, and it just performs delegate calls to the individual modules, very similar to like how the dispatcher itself works. But let's do touch on the revert here, the simulate batch call, because all of these actions, right, they are performed actually, but because of this revert case, we are and then being able to capture that using the eth call method in get, for example, or in the node, you're able to perform simulations as if they have happened, and then capture the results in this simulation. We use this really heavily in the front end to be able to perform all kinds of, or simulate all kinds of actions to a much deeper degree than most other applications can. It's really a quite powerful thing. Euler also explored this, and their implementation is a little bit different, but it has a similar idea. Oh, and actually notice the read entrant C allowed tag on these two. It's one of those places where it's allowed to happen, but there's no.
This is neat. This is really cool. zerosnacks. Because we're at 56 minutes or something. What I really want to see is the template. Like, how would I use this?
Sure.
As a dev.
Let's quickly jump into the template. This is something we put together alongside of reflex. It just shows a very, very basic thing, a basic simple structure. You see, okay, it points to reflex module, it points to reflex, we call it reflex state here, but it should be reflex storage. Let's jump in. So we have the app dispatcher. This extends from the reflex dispatcher. App state, we now refer to this as app storage. It's because state is a bit contentious and it has double meaning, so we want to avoid that, but it's the same thing in this logic. So in the same way we had reflex storage, we have app storage, app state. We define storage slot in a very similar way, and this is because we don't want to clash with the storage layout in the dispatcher. Because if you were using direct slot access, you definitely run into issues. But yeah, if you're interested in the spec, go to the reflex dispatcher, and there's a link there. Inheriting from the module here, just extending it just to make it accessible. And then we have modules. We have two modules here. We have a custom implementation of the installer, but we have an increment counter and a decrement counter. So this is kind of a high-level API. How do people use this? You have the app module. The reason why we're not using like reflex module directly is because you probably want to add custom logic, custom abstractions. That's why we kind of have these abstracts. So you have these two methods. One is a view method, the public method. Notice the way that interaction or accessing of storage happens. And so we have an increment counter and we have a decrement counter here. And then let's quickly jump into the test. That's where it becomes clear. So in the test, we set up a few things. We, of course, set up the dispatcher. We set up the installer. So set up the installer, set up the various modules, then set up the dispatcher. We pass in the installer. Then we establish, okay, this is my endpoint, because any interactions that happen need to happen with the endpoint, not the implementation. That's why we need it here. Then we can say, okay, install these modules at decrement counter, at the increment counter, at the modules. And then we can interact. Then we can start interacting, right? So we first establish, okay, what are my endpoints? And then we have a very simple case here. We call an endpoint, perform an action on it. In this case, increment. We can verify, hey, because the state, of course, is changing in the dispatcher. The increment and decrement counter endpoint, they both point to the same storage. So if I increment here, both values get set to 1, one value gets set to 1, but the pointers, right, the two different pointers point to the same value. We call decrement, and it verifies the same thing. So it just shows you how how modifying something in one module has an effect on another, because these are just views, these are just layouts on top of the storage layout in the dispatcher.
Nice. This is really cool. Where is Reflex used right now? So where is it in the development process, auditing wise, and stuff like that?
Yeah, actually, I'll speak to this. So right now we use it for a Light, which is a lending protocol we're building out. And we use it pretty comprehensively. Like, we use the batching and the simulating. We use like multi-endpoints to represent, sort of like C token equivalents of ERC4626 Vault. And obviously like normal endpoints to represent like various pieces of functionality. And so regarding the audit, we're going to do a public Cantina competition very soon. I probably have an announcement about that within, I don't know when this is going to release, but within like a week or two from taking this on April 10th. And so we'll have a public competition auditing this. Light is being audited right now by Cantina in a managed review. But Reflex is out of scope for that audit. We're going to do a public competition for that. And so that's kind of where we are in the process of development. And if anybody's interested in actually implementing it, it will be audited, and ready to go pretty soon. Would love to talk to you and help you set it up if this sounds useful for your project.
Nice, nice. No, that's a really, really awesome tool, guys. This is I'm actually doing some upgradability for Diet right now, and it's just a pain, to be honest with you. So if I had used something like Reflex from the beginning, would actually be super, super helpful. So yeah, very, very cool tool. Yeah, listen, guys, this was fun. I'm gonna put the GitHub repository in the description down below. Your guys' Twitter, Chroma as well. Anything else would be interesting to put in the description?
I think we covered most of it.
I don't think nothing.
Awesome. Then okay, sounds good. Then yeah, Jack, thank you very much, sir. Zerosnacks, thank you. It was a pleasure, and
Thank you.
see you in the next one, guys.
Thank you.
Bye-bye.
Pleasure hopping on.
Bye-bye.